Hi, today we're going to go through two structures that play a pretty big role in the endocrine system. So, the body, our human body, likes to maintain homeostasis. Homeostasis is our most ideal state where we're all getting the amount of nutrition we need. We don't have too much excess of one thing, and our system is pretty balanced. Now, there are two ways through which we communicate within our system and signal, and one is through neural communication, which is essentially using neurons. And the second form of communication is through hormones, which go through the bloodstream, through our body, through the glands they target. So the thing about neurons is they're quick, they're precise, and they're all or none. On the other hand, we have hormones, which work more through a diffuse type of procedure. They're more slow, and as I said, they're more diffuse, and they're not so precise. So you can think of hormones as little balls that, based on concentration and amount of presence, and they move around. Whereas neurons are literally like electrical impulses, like, hey, turn on, send the signal, stuff like that. Okay, so today we're going to be going over two specific systems, two specific structures in the endocrine system. The endocrine system is based on hormones and using hormones to communicate. So specific structures we're going to be talking about is the hypothalamus and the anterior pituitary. So the hypothalamus will initially release releasing hormones into the anterior pituitary. Anterior pituitary will then release hormones specifically through any other glands in the body through the bloodstream. So how this works is, a better way of putting this would be, we have two types of hormones. We have hormones of two types. First, we have releasing hormones. So now releasing hormones, which I'll abbreviate as RH, are released from the hypothalamus, and they go specifically to the anterior pituitary. On the other hand, we have tropic hormones. These type of hormones, which I'll abbreviate as TH, go from the anterior pituitary to whichever system is in the body. So you can think of this part of the endocrine system as the hypothalamus specifically controlling the master gland, and the anterior pituitary, which is considered the master gland, which will communicate with all other body parts. Now, some very specific pathways we can take, for example, is the thyroid. So you have your hypothalamus. We can also use this system. Yeah, let's just rewrite all that. Let me shrink the weight a bit. So you have your hypothalamus. Now, where our hypothalamus will release TRH, which actually stands for thyrotropin releasing hormone. Now, thyrotropin releasing hormone will go to the anterior pituitary and signal on the activation of stimulating hormone, specifically TSH, which is thyroid stimulating hormone. So you can think of this as a type of trophic hormone. Now, this thyroid stimulating hormone will go specifically through the thyroid, and this is how the thyroid looks. So I'll just write thyroid, and it will then thus release thyroid hormones. These thyroid hormones will now be in the bloodstream at a certain concentration. It will go throughout the body, wherever it needs to go. We got our thyroid hormones. However, these thyroid hormones will also come and rotate back to, they will come back and eventually get back to the anterior pituitary and also the hypothalamus. Now, the hypothalamus will always be releasing TRH. However, when this red thyroid hormone is released, it will actually have an inhibiting effect on the hypothalamus. It will inhibit the hypothalamus's production of thyrotropin releasing hormone. It will also inhibit the anterior pituitary. As a result, the inhibition of TRH will cause an inhibition of the activation of the anterior pituitary and releasing TSH, in addition to the effect we get from the thyroid inhibiting the anterior pituitary. And so we'll get a generally decreased effect. And so our thyroid will then also get less TSH, and as a result, it will release less thyroid hormone. Eventually, the thyroid hormone in our bloodstream will decrease again, and our inhibitory effect will then cancel out because there isn't thyroid hormone causing the inhibitory effect, and our hypothalamus will start releasing again TRH, and our anterior pituitary TSH, and activating thyroid and producing thyroid hormones. Now, so this is essentially a loop we got going on. And this type of loop is specifically a negative feedback loop. And it's a really good way for us to maintain and check for balance, because if we have too much of something, too much production, we go back. So we produce something, and once we have too much of it, once our reaches too much, we go back and tell our start to stop, or like essentially decrease. So this is a negative feedback system. Now, another very specific example we can also take is CRH. So again, it involves the same structures. The hypothalamus, which I'll write as hypo-T, it releases CRH, which is another type of releasing hormone, specifically corticotropin releasing hormone. This will then activate our anterior pituitary. That's a P, my bad. To release ACTH, which is adrenocorticotropic hormone. And this will essentially go into its target cells, and release cortisol. And similarly to our other system, we will then have cortisol floating in the bloodstream, eventually come to the anterior pituitary and the hypothalamus. And it will also have an inhibiting effect, where if it's too much cortisol in the bloodstream, our hypothalamus will be inhibited in its production of CRH as well, and then as a cascading effect, ACTH, and then we will decrease the production of cortisol, and then we'll re-get that homeostasis again. So this is how we maintain this balance. So that's essentially what we got for these two structures, the hypothalamus and the anterior pituitary, its role in the endocrine system, two general types of hormones. Well, there can be more types, but those are two kind of core type hormones, the core structures, and then, yeah, pretty much